Hi guys, today we will be starting with organic chemistry for class 10 students. Now what is organic chemistry? Organic stands for anything that is derived from biological sources like plants, animals, etc. Right? And if we move into the elemental analysis, then it has been found that organic compounds consist of many elements. Carbon, hydrogen, oxygen, sulfur, any halogen, suppose chlorine, fluorine, etc. Nitrogen also, phosphorus also, okay. But out of all these elements, we have to focus on carbon. Carbon is the skeletal element in organic compounds. Skeletal means framework, guys. So we have to understand why carbon is the framework. Why is it so important for organic compounds? So reasons behind carbon to be important can be listed in two headings. Number one, catenation. Now what is catenation? Catenation means carbon can make long chain compounds, like you can think of a compound in which carbon is joined like this. So as you can see guys, carbon is making a bond with carbon itself. So catenation can be called as self-linking. It is self-linking. Carbon is making a bond with carbon itself and the chain is propagating. It can propagate in this direction, so on, in this direction. It can also propagate up and down. It can also make a compound like this. So this property of self-linking of atom with each other is called catenation. Okay. So we can write self-linking of atom with each other to make straight chain, branched chain, or cyclic compounds. This property is termed as catenation. I would suggest you to write the definition given in your book. This is the definition in short, you can say. Okay guys. And one more thing, cyclic compound is like this. It is forming a cycle. It is not open on both the ends. You can make a cycle like this also. Then it is a 4-member cycle. Minimum cycle is a triangle, right? It is a minimum cyclic compound. Another property due to which carbon wins the race in organic chemistry, it is tetravalency. I hope you all are aware of the term tetravalency. Guys, what is tetra? As you know, mono means 1, bi means 2, tri means 3, tetra means 4. And what is valency? Valency means number of bonds an atom can make. So, carbon can make 4 bonds. That is called tetravalency. Once again, tetra is 4, valency is bond. So tetravalency means carbon can make 4 bonds to attain what? To attain what, guys? Any atom can make bond. But why? Why does atom make bond? The reason is to attain stability, right? In class 9 we have read about it. If you remember, bond stands for stability. And stability is explained in 2 ways. One is duplet stability, another is octet stability. Duplet stability means in the first shell only 2 atoms will be there, okay, and duplet stability is also for 2 atoms only, that is hydrogen and helium, because they have only one shell. So duplet is for orbit number 1, that is hydrogen and helium. Octet is for other. So if I write orbit as n, so in this case n will be greater than 1 for octet stability, having 8 valence electrons. So I hope quickly we have revised what is stability. So in this case also carbon can make 4 bonds to attain stability. And what stability? In particular, octet stability. Octet stability. If we quickly take an example, guys, suppose carbon has electronic configuration 2,4. That is, in the K shell, carbon has 2 electrons. In the L shell, carbon has 4 electrons. The last shell is termed as valence shell. You all know, right? So this is the valence electron. Now, carbon is not stable because in its valence shell, carbon has 4 electrons. We know in order to be stable, either the atom has only one orbit, which is not the case for carbon. So we have to move to octet rule where n is greater than 1. Yes, you can see carbon has 2 shells, that is greater than 1, and 8 valence electrons. But as you can see, carbon has only 4 valence electrons. So how will carbon make it 8? So carbon will go into a sharing process, guys. Carbon will share the 4 electrons with another atom. Carbon has 4 valence electrons, as you can see. Now it will share the electrons with hydrogen atom. So hydrogen has 1 electron only. So hydrogen will attain the stability by completing its duplet. So carbon will share 1 electron with the 1 electron of hydrogen, and in that way hydrogen will complete its duplet. As you can see, in this way hydrogen, the 4 hydrogen atoms will complete the duplet. This orbit is actually the orbit of hydrogen atom, and in this orbit hydrogen has 2 electrons, one of its own, another gained from carbon. If I hide the other part, in this particular orbit hydrogen has the duplet. All other hydrogen has completed duplet. So now it is the turn for carbon. So carbon will attain the octet. It has 4 valence electrons of its own, and it will attain 4 other electrons from the 4 other hydrogen atoms. So this orbit is belonging to carbon. In this particular orbit we can find total 8 electrons. That means carbon has completed the octet, attaining 4 electrons from 4 hydrogen atoms. Now if we move into the bond diagram, hydrogen and carbon will make one bond each, that is single covalent bond. As you can see in the diagram, since carbon and hydrogen has shared one pair of electrons, one pair because one coming from carbon and another coming from hydrogen, so it will make one bond. So in such a way, 4 hydrogen atoms will share 4 pairs, one from hydrogen, one from carbon, and we will get 4 single covalent bonds. This is the concept of covalent bonding, guys, which you are familiar if you are from Icse background, because in class 9 we have already done covalent bonding. If you are from CBSE background, this is something new. So this is the concept of sharing of electrons by which an atom can attain the stability, that is either duplet or octet. This molecule that we have done, this is called methane. It has the formula CH4. Even if we do not know the formula, we can make it out easily. Okay, there is no need to memorize the formula, guys. We can make the formula of our own. For example, we are moving to carbon dioxide next. We know carbon has 2,4 electronic configuration, and if we look into oxygen with atomic number 8, it is 2,6. So carbon has 4 valence electrons and it requires 4 more to attain the octet, right? So we can write 4 plus 4 equals to 8, that means 8 valence electrons. Similarly, if we move for oxygen, oxygen has 6 valence electrons. So if we add 2 more, it will attain the octet, 8. So both carbon and oxygen will attain the octet stability by sharing. Now we have to equalize this 2 number, that is carbon will share 4 and oxygen will share 2 electrons. Like in maths we do, right? In equation, suppose we have equation 2x plus something equals to something and 3x plus something equals to something. So how do we do? We multiply the first equation by 3 and the second equation by 2 because we want to equalize the coefficient of x. In the similar way, if we want to equalize this 2 electron number, so we have to multiply oxygen with 2, right? So we get 2 oxygen atoms and 1 carbon atom. So what is the formula? Formula will be C1 and O2, that is CO2. So guys, I just told you there is no need to memorize the formulas. Here we are showing the electron dot diagram for the carbon dioxide molecule. We will only show the valence electrons. Okay, remember, not the total number of electrons, only valence electrons. So as you can see, for carbon I have put 4 cross and oxygen I have put 6 dots. So oxygen will share 2 from each side of carbon. In this particular orbit, oxygen is having 8 electrons. If we hide this part, and now if we hide the other part, we can see that oxygen will be having 8 electrons in this orbit. So both the oxygens have completed their octet. Now it is the turn for carbon. Carbon has 4 of its cross, so it requires 4 dot. So it will include 2 and 2 electrons from the 2 oxygen atoms in its orbit, and in this case we can see that yes, carbon has also completed octet. So in this way we can get the stability in carbon dioxide. Now since carbon and each oxygen atom has shared 2 pairs of electron, we will draw 2 lines. 2 lines means double covalent bond. Like in the previous case, we showed 1 bond for 1 pair of electrons being shared. These red electrons that I am now showing, these electrons are already present on oxygen atom, but they have not taken part in sharing. Out of the 6, oxygen has shared 2, right? So 4 more electrons are present on oxygen which have not taken part in sharing. So these pair of electrons are called lone pairs. Lone pairs means these are the electrons which are not involved in bonding. So in this way, both the oxygen will have 2 plus 2, 4 lone pairs. We can see carbon dioxide as an example of total 4 lone pairs and double covalent bond. Double covalent bond because it has shared 2 pairs of electrons with each oxygen atom. I hope this part is clear, guys. So you can practice other molecules as your homework. Now I am showing you the third example, okay? But before moving into the third example, you can try at your home nitrogen molecule as your homework. Nitrogen molecule means I am talking about N2. It's a diatomic molecule. If we move into the third example, that is ethyne. It's an organic molecule. The formula, the naming, we will all learn about it in our coming classes. But now in this case, I am already providing you the molecular formula. It is C2H2. If we look into the bonding concept, we have 2 carbon and 2 hydrogen atoms, right? Now we will only show the valence electrons. So we have drawn the 2 carbon atoms. Now I know that hydrogen has 1 electron. So it can only share 1 electron to complete its duplet, like it has done in methane also. So with each carbon atom, 1 hydrogen atom will share 1 electrons, okay? So now you see in the coming part, I have shown you that 1 hydrogen atom will be sharing its electron on either side of the molecule. This is the electron of hydrogen and this cross is the electron of carbon. So 1 sharing, right? In the similar way, this carbon also will share 1 electron with 1 electron of hydrogen. So hydrogen has completed its duplet. And what about the other 3 electrons of the carbon? This carbon has 3 more and the other carbon also has 3 more. First, we will see how the hydrogen will complete the duplet. The green orbit is belonging to hydrogen with its completed duplet. This is also the completed duplet of hydrogen. Now what will carbon do? Each carbon has 4 cross. So it requires 4 more. So it will take 1 from hydrogen and 3 other electrons from the adjacent carbon atom, right? So you can see I am making the orbit for this carbon atom, okay? In this orbit, you can see there are total 7 cross, 4 of first carbon and 3 from the other carbon and 1 dot. So total 8. As you can see, I am counting. It is total 8. Right? You have all understood the octet concept. Now this is the time for the other carbon also. So this carbon also, like the other carbon, it will share the other 3 electrons from the adjacent carbon and 1 electron from hydrogen. Okay, the color is not such prominent, so I think you have got the concept. How will we now make the bond? With each hydrogen atom there will be a single covalent bond because 1 electrons have been shared, that is a pair of electrons, sorry. And between the 2 carbon atoms, 3 pairs have been shared. As you can see, I am drawing the dots. 3 pairs of electrons have been shared between the 2 carbon atoms, which will make 3 lines. So this stands for triple covalent bond. So ethyne is an organic molecule with triple covalent bond. As you can see, guys, in the left hand side bottom, I have listed down below 3 molecules for your homework. Nitrogen molecule, which you can practice, ethene and ethane also. Comment down below if you face any difficulty in solving the homework. In my upcoming video, I will be sharing the IUPAC nomenclature of organic compounds as well as the homework that I have given you. So guys, solve these 3 examples as your homework: nitrogen, ethane and ethane. If you face any difficulty, comment down below and let me know. In my upcoming video, I will be discussing the IUPAC nomenclature of the organic compounds and the homework also. Bye.